Great. Well, good morning, ladies and gentlemen, and welcome to day 3 of Genetic Genealogy Ireland 2013. And it gives me great pleasure to start off today's proceedings with the Director of the International Society of Genetic Genealogy, Katherine Borges, who has come to us all the way from Northern California. Now, Katherine has been Director of the Society since when?
2005.
2005. And I'm going to turn your microphone on as well, so we're all set to go. And Katherine will be talking to us today about the basics of DNA testing, and will give you an idea of what each test does, so you can make a decision about which test would be best for you. So would you please welcome Katherine Borges.
So thank you for that introduction, Morris.
I'll go on.
And for those of you, I'm not sure how many of you know Americans. Some of you are Americans, but if you've ever asked an American, without knowing they're an American, what they are, and we do this all the time in America too, we usually don't say we're American unless we're in other countries. We usually say, I'm Irish, I'm Scottish, I'm Portuguese, I'm whatever ethnicity we are. Because if you think about it, our country has only been around a little bit over 200 years. And we don't consider, baseball and hot dogs our ancestral identity. I mean, yes, we may be patriotic and whatnot, but that isn't how we're raised, and that isn't who we are. I mean, we have Scottish Highland Games. We even have it where I live in Central California, which is very rural. We have Irish heritage festivals, all kinds. So, and we're raised like that. Our parents raised us to be proud of our heritage. Some of us Americans are from recent immigrants, and some are from, colonial immigrants. On my direct maternal line, I'm from an Irish family immigrant, so I do heavily identify as being Irish. So, to begin, the 3 most important things you need to know when you get into DNA testing is the types of DNA tests, because you don't have just one kind of DNA in your body. You have several types of DNA, and those different types of DNA are used to tell you different things about your ancestral makeup. And then those DNA, the different types of DNA that you have in your body, have different paths of transmission, which I'll be going over, and it's very important for you to know that too, so that you know what DNA can be used for your genealogy, and how it can work for you. Because you shouldn't just order a DNA test. We don't want you just outright ordering something willy-nilly and you end up with something that you don't need. So I'm a big believer in you should go into it with a goal and have a goal and purpose for the particular test you choose to do. For the most part, when I give DNA speeches, I try to speak very simply, because for those of you that might be beginners, I have been in your shoes. When I first learned about DNA, this is my 10th year now. I learned about it 10 years ago, and I became a volunteer DNA project administrator 10 years ago this month. This is my 10-year anniversary. And in the beginning, it went, as we say in America, over my head and under my feet. I did not understand DNA at all. And so when I speak about it, I try to do it simply, but there are some terms I just can't escape. There's not many substitutions for words like this, but I will try to do the best I can. So the first type of DNA that we use, and it's the most commonly used when using DNA for genealogy and ancestry purposes, is Y chromosome DNA, and sometimes you hear it referred to as Y DNA. And the Y chromosome is the male gender chromosome. So the male receives a Y from his father and an X from his mother, and females receive 2 X's from their parents. That's what makes us females. So when a female like myself wants to do Y chromosome testing, I obviously have to get one of my relatives to pony up and provide the saliva for it, so that I can do that type of testing. That's called testing by proxy. The second kind of test that came out and is as popular, it's actually been around one of the longest because it's used a lot in ancient DNA, is mitochondrial DNA. And that is the DNA that's passed down to all maternal lines. So males have it too, but they do not pass it on to their children. Only females pass mitochondrial DNA. We also refer to it as mtDNA. The third kind is that SNP. I usually say SNP. You hear people will say SNP or they'll say SNP. Either one works. but it's an acronym for single nucleotide polymorphism. So you can see why we prefer to call it SNP or SNP, because single nucleotide polymorphism is a mouthful. And what SNP testing does is it confirms the deep ancestry on either mitochondrial DNA or Y chromosome DNA. So you can get that confirmed on those two types. The only company I know of that does SNP testing automatically and for free on mitochondrial DNA is Family Tree DNA. And then for the Y chromosome, SNP testing is done by many companies, and that usually costs an additional fee. But when you do YSTR testing, you do get a prediction of what your SNP will be on the Y chromosome through most companies. And then the fourth kind of DNA testing available is Autosomal DNA, which tests your recent ancestry. Now that test has also been around a long time, but in the beginning, it just gave you percentages of what your ancestral makeup is. But there's a caveat to that, because it will give you those percentages based on whatever company's database you test with. And all companies have different databases. So you can test with one company and be one thing and have one type of percentage, and you can test with another company and have another type. So it just depends on what is in the company's database, and also how many people have tested and how many samples. And some companies also cater to specific demographics, like Henry Louis Gates, who is a Harvard professor, and he does a lot of TV shows in the US on PBS. He has his own company, which is African DNA. So obviously his company caters specifically to Africans and has a preponderance of that kind of DNA. So, but nowadays, since 2009, we've been able to use autosomal DNA for recent and genealogical purposes, and it's a very powerful too. It's one of my favorite tests, and you'll see why in a little bit. So where does the DNA come from? I get that question a lot, because people will come up and say, well, how do you get your ancestors' DNA? How do you know you have a common ancestor? Well, it's because that DNA is in you. It's passed on down. And there's basically only two ways to get it. And one of the first ways, and especially in science, that came about was extracting DNA from ancient remains. And you've probably seen lots of articles about that. I mean, here in Ireland, I just recently heard that they've been able to get DNA out of one of the bog mummies. But generally, bogs have a lot of acid in them that break the DNA down, and they don't usually get DNA out of there. But another one that's famous in the British Isles is that they've extracted mtDNA from Richard III's remains. So that's a big discovery out of Leicester University in England. So, but on this particular instance, why I have Marie Antoinette up here, maybe I should change it to Richard III, but this is kind of interesting, and it also applies to the question I get a lot, is Marie Antoinette had a locket, and inside the locket was a lock of her hair, and it hadn't been opened, I don't know, in over a century, a very long time, and so this hair had stayed preserved in this locket. It hadn't been contaminated, it hadn't been touched. And in the 20th century, they opened, or 21st century even, they opened the locket and were able to get viable DNA out of the hair and tested it. And then in France, they found a goblet under a cathedral that was labeled, it had a heart and a petrified heart with her son's name on the goblet. So they tested the hair, they tested the heart, they matched each other on the mitochondrial DNA, and they held a state funeral for her son in 2004. Now, the reason I use this example a lot is because people will come up and say, I don't have any source for a particular ancestral line. Can I do a hair test? Because some people have, I'm not sure how common it is in Ireland, but in America we have hair wreaths as morning pins. I even have a morning pin from my great-grandmother. But the thing is, a lot of times people touch hair, and even hair that's packed away in an envelope, so it breaks down, it gets contaminated. So it's very hard to do hair testing. It's also expensive. But I think as technology advances, we might see more of this forensic type of DNA testing come into the genealogical arena. I, for one, have stamps. I have stamps that I'm saving from my ancestors, so I look forward to when they can get viable DNA, especially Y DNA, out of stamps, because like my McCallum line, which originated here in Ireland, I have no male McCallums in America that I can test. All the lines have dotted out, so if I want my grandfather's DNA, I have to get it from a stamp. So But generally, in genetic genealogy, we do not get it from hair or stamps or anything like that. We get it from a swab of saliva inside the mouth. Now, there are some companies that have you expectorate into a vial too, but it's all done with saliva. In the early years, when this first started coming about, it was done with blood tests, but most people are, or not most, but a lot of people are skittish on blood tests, or leery, so they went to the expectorating kind and the swab kind. But it's done with an anthropological field kit, so it works just fine. So as I mentioned before, it's important to know the transmission paths of the different kinds of DNA testing available. So this is the path of Y DNA. So when you have a male child, the Y chromosome is passed on down the male line just as surnames are. And in the British Isles, for the most part, there are some exceptions with Wales and clans, because Wales adopted a patriarchal surname system late. But for the most part, surnames are passed on down the male line. But there are other European countries that you cannot use Y chromosome testing for. Like, for instance, my surname of Morris pronounced it correctly, is like Borges, but it's in America we say Borges. It's Portuguese, and the Portuguese did not adopt a patriarchal surname pattern until 1900. So prior to 1900, children would take the mother's maiden name. They might take an ancestral surname of a noble family, like Avila or Betancourt were noble names. So sometimes doing Portuguese genealogy is madness, because you'll have a list of children, half will have the father's surname, the other half will have the mother's. But you can't do surname testing for Portuguese, so it's very difficult. So for when you can't do that type, and this also applies to some other groups too, you see this sometimes with clans or other instances, like maybe with Irish fostering where there's a surname change. There are geographical DNA projects, and there is an Ireland Y project, and there is an Ireland mitochondrial project, which Morris and I are co-admins on the Ireland mitochondrial. So this is a Y chromosome tree. Scientists have been able to map the tree back to one man, and that's why it says Adam in quotes, just to call him that. But we all descend from one man and one woman. And on this tree of the Y chromosome, this is the deep ancestry, it gives you a letter combination, and then it goes out to a letter number combination, and that tells the origins. So starting on this tree, whoops, I don't know what happened there. But anyways, the most common type in Ireland is R1b. That's the most common. It's Western European. And Trinity College in Dublin had a study in 2006 where they were able to refine a variety of this R1b down to Northwest Irish. So you're very fortunate here in Ireland if you're able to have that type of Irish DNA, because you have a specific one, whereas England and a lot of the other countries aren't able to have that specificity yet. So this is what DNA results look like for a Y chromosome test. These are called STRs. It gives you numbers at certain locations on the Y chromosome. And this is for an American of Irish descent. And when you get the certificate, you don't really derive much value from it until you're able to compare the results with other men with the same Y chromosome. And so Family Tree DNA has a Withrow project, and this gentleman joined the project. He had a very good paper trail back to his ancestor in Ireland. And there were other people with the same surname as him that were brick-walled. So because he tested, they were able to match up to his results. And that's where one of the things that could possibly help those of you that are Irish that are stuck on a surname brick wall, because with your 1922 records destruction, you might be able to link up to an American that does have the paper trail back, to Ireland or I'm not sure, but maybe Scotland. But anyways, that's an example of what you can do with it. Another thing you can do with it is his particular DNA, he didn't end up being the Northwest Irish type. He's actually very similar to Scots, and it's called Scots modal. And as most of you know, there was a lot of moving back and forth between Scotland and Ireland in the past, so his DNA is more Scottish than Irish. And then one of the projects that I also volunteer that I admin for is Clan Malcolm McCallum. And Malcolm is the original name, and then McCallum are all derivatives or variants. And one of the interesting thing about the McCallum Project, and my McCallum ancestors were from Ireland. They immigrated to Scotland, worked in the coal mines in Lanarkshire, and then immigrated to America. So that was their migration path. Is that, as most of you probably know with clans, not everybody in a clan is going to be related. You know, maybe sometimes Americans don't always realize that. Probably most people in the Isles do. But people joined clans as protectorates, and so that they're not all going to have the same Y chromosome, and you can see that here. But one of the things that fascinates me about the project is, especially like in this group 4 is a good example, is that all of these males share a common Y chromosome. They all share a common male McCallum ancestor, and they have different variants of their surnames. This one's McCullum, this one's Malcolm. McCullum with the O, this is McCallum with the A, this is McCullum with the U. So even though their surnames changed over time for whatever reasons, like when my ancestors immigrated from Scotland to America, they they added an A, so it went from MC to MAC. So I don't know why sometimes that happens on immigration. But anyways, that's one of the powerful things you can do with the Clan Project. Did you have a question?
Yeah, I'm just curious, what's the commonality? How do you read this?
Well, these numbers here match up, and then I know it's kind of hard to see from far away, but see the yellow and the blue? That's where there's changes in the Y chromosome DNA. Those are called mutations, but a mutation, really all that is a change. Y chromosome tends to mutate and change faster than, say, mitochondrial DNA and other types of DNA. But the thing is, it's useful for seeing patterns in the DNA. See, like these 3 men right here have 11 while the others have a 12. So that means they might be more closely related and share a more recent common ancestor. So that's one of the helpful things about it. Some of these markers on the Y chromosome change faster than others, but family tree DNA gives you a lot of that information. They're really very helpful with that, so that you're able to figure that out. Plus you have volunteers like myself and Morris who help people also read the results. On the McCallum Project, my co-admin is one of the McCallum clan leaders. So this was an example I put in there with the Borges on how, as I mentioned with the Portuguese, they did not adopt a patriarchal surname system. It's highly unlikely where my husband would ever get a Borges match. But he did get a match to a Serpa, and that Serpa happened to live only 60 miles from us in California, and we actually got to meet him. But they do share a common ancestor in the Azore Islands. And they also have a unique kind of DNA. In the Azore Islands, they didn't have just Portuguese immigrants. They had Spaniards, they had Flemish. There was a war with Flanders. So my husband's Y DNA actually might be Flemish because it's not that common in Portugal. It is found in mainland Portugal, but it's not that common. So another thing we can do too is compare DNA to scientific studies, and that was a study that was done by a scientist named Balaza. And so my husband has a match to a person that's in Porto, Portugal. So even though they've been in the Azores since the 1430s, and that's as far back as the records go for that, the DNA can give a match to mainland Portugal, and you might know what region in Portugal they originally were from. And that's the scientific study that it came from. And another thing that you can do with it, which is also very helpful for Ireland, is you can do mapping. And Family Tree DNA gives you, you have a map with your results, and then it'll give you close and nearby matches, and when you click on it, it'll tell you the information. If the person has entered it, though, that's the caveat. They have to have entered the information, but what their most distant ancestor is, where they came from, that kind of thing, so you can narrow it down. Another one of the projects that I volunteer for, admin for, is Lyons. And Lyons is a surname that's found in Ireland, Scotland, England, France, and Germany. And a lot of times when you're brick-walled with that surname, then it's hard to know where it originated or what country it came from. Well, there is a lion line that is very old that supposedly came in with William the Conqueror. And that lion line is the same lion line that the Queen Mum, who was a lion, she's related to that line. And even though she doesn't have a Y chromosome, we know that she's related to that line because of the genealogy. This particular lion line also did have people that branched out, not only, most of them are in England, but they also went to Scotland and Ireland too. So that's one of the other powerful things it can tell you when you can match up to an old lineage like that, no matter how brick-walled you are. So the path of mitochondrial DNA, as I mentioned earlier, it's all along the female line, the maternal line passed down, and then males don't pass it on. And this is what the male's transmission chart looks like. This is what my father's mitochondrial DNA certificate it looks like, and he is a haplogroup H. For those of you that might have read The Seven Daughters of Eve, that's one of the most common haplogroups in Europe and in the British Isles. And I would highly recommend, too, reading that book, especially if you want to get in and learn more about mitochondrial DNA. It's a good starter book. So he has a very common kind of DNA, but here's the thing is, now my father, that's my father right there, and me on his back, and my father was an only child, and he died in 2003, and I tested him that same year before he died. He got cancer and died, but family tree DNA stores the DNA for 25 years. So if I had not tested him when I did, I would not have been able to upgrade his results and know what his mitochondrial DNA was because he had no siblings. Now his mother was the immigrant, and this is my grandmother, and she was an only child, and then this is my great-grandmother, and they're Scottish. They're from Aberdeen, Scotland, and the great-great-grandmother. So I would not have been able to learn what my father's origins were if I had not tested him. So to me, there's an importance of testing people now, and why you might want to develop goals like that, especially if you have older family members too, and like that you want to be able to store and bank the DNA, because again, if you have a relative test, then you're testing by proxy, and you can upgrade the results. So one of the ways that you can use mitochondrial DNA, because it is kind of difficult to use because females don't keep their surnames, and because the records are so poor for us. Oftentimes you might find a will and it says, my wife Elizabeth and no maiden name. So, Kelly, a good Irish name. These two descendants here had a theory that these two women, Martha Kelly and Katherine Kelly, were sisters. So they both did a mitochondrial DNA test and they matched each other. Those are the results in the match over there, and that it corroborated the fact that Elizabeth Cummings was a common ancestor. So that's a way that it can be used for genealogy purposes besides just learning your origins from mitochondrial DNA. This is the daughter of my immigrant Irish ancestor that came from the potato famine. And her DNA, when I DNA tested, I fully expected to be something that was indigenous to Ireland, because after all, that's where my mitochondrial line is from. So imagine my surprise when my results came back and I was a type of, my haplogroup is called N, which is not indigenous in Ireland. It is found in Ireland, but it is not from here. I was a bit surprised. And the thing about that is most of my matches were from Italy, nearly all of them. And so all you can do when you don't have the records is develop a hypothesis. So the hypothesis I have for this is that my long ago female line ancestor came with the Romans into Britain and then went into Britain during Cromwell's reign. And the one kind of clue that I have that they might not have been Irish is her mother's surname is English. Her name is Julia English. And English is not an Irish surname. It's quite common in Cork. There's lots of people in Cork named English. And that's where they originated from. That's where the ship sailed from too in 1848. But English is not an Irish surname. Now, they self-identified as Irish. They settled in Chicago. They lived in an Irish section of Chicago. I even have a O'Leary great Chicago fire story, my ancestors were at the party, that kind of thing. But, so then the next question that it kind of begs is, I find out that my mitochondrial DNA is not indigenous to Ireland. Does that make me less Irish than I previously thought I was? And answer is no, at least for me it's not, because it's just a piece of information and you can incorporate it into your identity if you want to or not. And the way I look at it is my ancestors self-identified as Irish Catholics in Chicago. So as far as I'm concerned, they were Irish. Because when does somebody become one thing and stop being another? I mean, a lot of you probably have Huguenot ancestors that immigrated to Ireland or to other places in the Isles. And, so originally they might have been French, but then if they came in and they intermarried with Irish or Scottish or whatever. So again, your identity is part of you, and DNA is just a piece of information. So as far as I'm concerned, I may have, like, say, an Italian origin on my mitochondrial DNA, but I still consider myself a huge chunk of Irish. So this is a map, too, that I did for someone who, this person also has the same haplogroup type I have that also went up to Ireland, and then showing how it went to America. So that's one of the things you can do, is track a migration route with your mitochondrial and your Y-DNA. Now, autosomal DNA is the DNA that you receive from both your parents. And this chart is supposed to show how here's your mom and dad and you, and then it covers all these branches. And that goes about 5 generations. I see plenty of success stories that go back to 1600s. So I tell people, if you have your genealogy done back to the 1600s, go ahead and enter those surnames and those ancestors, because you may get a match on them. So the other thing it does too is it gives you an ancestral makeup. This is my brother. It shows him as being 100% European. As time goes on, you will see this refined down as science advances, like with these different studies that are coming out. Like in England, there's one called People of the British Isles. And then what's the Irish one?
The Irish DNA Atlas.
The Irish DNA Atlas. So as this DNA, the scientific data is added to the DNA databases, then we'll see it refined down and not so much 100% European. Now, here's something interesting though. When, a lot of Americans are mixed, and I'm one of them. I'm Scottish, Irish, and I also have an ancestor who's from Bohemia, which is now present-day Austria. So when I got my pie chart, I have what I call a pizza slice of Jewish DNA that my brother didn't inherit. So siblings get different DNA from their parents. They don't inherit an exact replica 50-50. Not even identical twins are 100% alike. There was a study that came out several years ago about that. But I'm guessing that my pizza slice of Jewish DNA came from my Bohemian ancestors, but I don't know for sure. Maybe in time I'll find out. And my son has a pizza slice of Native American DNA. He has one more pizza slice than I do, because he has Native American DNA from my husband's side. So this is what actually Family Tree DNA just changed their system, but I haven't incorporated the graphics into my PowerPoint yet, so it's a little, this is the older version. But you get a map of your 22 chromosomes, and these are 3 known cousins. I'm very conscious about privacy, so I asked my cousin's permission, and I don't want to show strangers' names, but you do get matches to strangers when you do this kind of testing. So these are 3 known cousins. The one that's orange, he's my first cousin once removed. So I'm the dark blue, and everywhere you see the orange is where we share DNA in common from our ancestors. And the other 2 are 4th cousins, and so there's only little sections where I share DNA with them. But one of the great things for me, I told you this is my 10th year doing this, and I used to, because in the beginning it was all Y chromosome testing, I used to have to sweet talk all my male relatives into providing DNA tests for me so I could get the surnames, but now I'm able to see it in myself. So I can see my own father's DNA in me in little sections like this where it overlaps, and only in those places where we have a common ancestor. The other thing you get too, and this is my son's results, is and this is really good for the genealogy purposes, is it gives you who you match. You can contact them by email. The computer will, based on the amount of DNA you have in common, it will predict how you're related. You can confirm it over here or not. That one says pending. That's my brother. And then if you have entered the surnames, it will highlight all the surnames that you have in common. And then that way you can see, hopefully find a match. The only problem is not everybody knows my advice about adding everybody back to the 1600s, so sometimes it's still good to contact the person to see if you do have a common ancestor that goes back farther, because they don't really realize that they should enter ones back that far. But another thing I want to point out to you, for those of you that know people or are related to people or adopted, you might even have adopted children, this is also a way for adoptees to find more about their ancestry, because again, like I said, it'll give you a prediction on how you're related, on how close you might be. And it can also give you that information about your ancestry you might not have with the brick wall of adoption. So for more information, as Maura said, I'm the director of ISOGG, which is the International Society of Genetic Genealogy. It's a free society to join. There's no fees or dues. Our theory is that if you have the extra money, use it for a DNA test. You don't need to be paying more society dues. And we have a wiki that is chock full of information. We have mailing lists where you can ask questions for free. We also sponsor tables and things at events. Like we've been at Who Do You Think You Are, had a table there in London for the last 5 years. And so if you ever get a chance to, I highly recommend that conference. It's you know what, the Who Do You Think You Are conference is bigger than anything in America. I have never ever seen a conference in that scale, that scope, that size, and with the number of people. They get between, you know, on average 11 to 15,000 people at Who Do You Think You Are. So it's really worth going over for that. I also have some books to recommend. I mentioned Seven Daughters of Eve earlier. You probably have that in the library. You can find it on Amazon.com. Another good book is the companion guide to, but this is to the American version of Who Do You Think You Are. The first season, it's written by Megan Smolniak. But if you're new to genealogy, I highly recommend this book because it's a great starter book, and it also has a good starter DNA section in it too, along with a companion guide on the American version of the series. 2 more books that I recommend are DNA and Social Networking by Dodie Kennett. She was actually here yesterday. She's one of the speakers, but she had to fly home to England today. And again, it's a great starter book. And she's usually always at Who Do You Think You Are every year. So if you do decide to go over there, if you get one of these books, you can have her sign it. And then also Chris Pomeroy, who's written Family History and the Genes. Both of these books, being that they're written by English authors, are more tailored to British Isles ancestry. So his book is available through the National Archives. And so that's all I have for right now, and I'd be happy to answer any questions. Thank you very much.
Thank you so much, Kathy. Let's take a few questions, starting with Sean.
Just one thing I want to clarify in my mind. When you go back to the chart of the 2 chromosomes, is there any order? Is it the male chromosome first and the female chromosome second? Or how does that chart relate to the actual chromosome source?
Could you maybe point it? I'm not sure which chart you're referring to.
That one.
No, it's. Sorry, I'm still mic'd up. Thank you. So this is autosomal DNA, which you get from both parents. So it's not the same as like doing a Y chromosome test. I mean, those are your chromosomes, but it could be from either parent.
So what does the first bar or the second bar not relate to anything particularly, or?
Well, not with gender, but it does with ancestry. Like for instance, because this cousin, he's my father's first cousin.
Right.
So all these areas of DNA, oh sorry, I keep doing that, inherited is from my father's side. So this section of DNA is from my father's side, and then other parts would be from my mother. The computer does allow you to click, and you could put I should do that, actually, that's a good idea. Put an ancestor up of my mother's side, and then you can see the different segments of where I've inherited DNA from my mother and my father.
So what I'm actually referring to is this section compared to that section. They've got no relevance to gender.
No.
No. Right. Okay. That's just what I wanted to get that clear.
Yeah. No gender. That was good though. That's a good question.
I spoke a little bit about this yesterday because people get a little bit confused because, first of all, there's only 22 chromosomes here, and we know we've got 23 chromosome pairs, but each one of these represents a pair. But the machine is not able to distinguish between the copy of chromosome 12 you got from your mother and the copy of chromosome 12 you got from your father. So it just reports it as chromosome 12, but that particular matching segment there, it could either be on chromosome 12 from your mother or chromosome 12 from your father.
Right, that clarifies it.
Good. And any other? Yes, we have questions down here. I'll take this lady first and then come to you. Thanks.
I had a Y done for my father, last name Spoley, on family tree. and I did 37 markers, and I have no matching Foleys. Now, Foley's a common name, it's like a Smith, so forth. I joined the Foley family surname through family tree DNA, and I'm all hooked up and so forth. But since I have no Foley matches with my 37 markers, how are they able to, because I did not do the deep clad test, how are they able to tell me you match up with this person and this is now your deep clad when I never had a match to begin with? Does that make sense?
Yeah, so let me go back to this marker because the slides, so it'll be easier for me to explain. Because this did take me, when I was starting out, it took me a while to comprehend this. So on these Withrows, right here, it has a haplogroup prediction. Kind of when she said deep clade, the deep clade, it goes back to that SNP, the SNP test that she's talking about. It confirms your deep ancestry. A clade is a branch of the tree, this is a little branch. So this is called a haplogroup, and these are called haplotypes. And a group of haplotypes, when you have a whole bunch together, like say maybe this chart's better. This is a whole bunch of people with a different surname. Not nearly all of them. There's a couple that are the same elders down here, but for the most part, they have different surnames, but they have very similar DNA. Their haplotypes are similar. So scientists can take a group of STRs like that, and because they know what the haplogroup for these STRs are, they're able to predict what the haplogroup will be. So that's how they know what your Foley is, a prediction. But the only way to know for sure is with a SNP test, and these ones that are in green are ones that have had SNP tests done to confirm that deep clade. Now here's what I'd recommend for your Foley too. So you have no matches. So first of all, I would recommend to joining the Ireland Y-DNA project if you haven't already added results to it, because they do a lot of mapping, and if by some chance, because there is always a chance that it might not end up being a Foley, with Irish clans and fostering and things like that, then you might be able to find it by comparing your results in the Ireland project. Secondly, if there's other Foleys, come in, like I'll give you an example. I have a cousin who's a Wallace, and he was in my slide, but I didn't use his YSTRs. His DNA has not changed at all since the ancestor. It's a perfect match to what the ancestral DNA is. And because he has no changes, he has to keep upgrading. So he's had to go from 37 to 67. And then the most you can do is 111. Now, unless you have a very common surname like Smith or maybe Kelly or something that's very common, Jones, Martin, Johnson, I would not recommend going out that far. I'm more of a person like do it on a basis as you had to. 37 is a good place to start, and then if you have to upgrade, then keep going. So that's what I'd recommend on your dad. Is first thing is add them to the Ireland Y-DNA, and then if any other Foleys come in, you might need to upgrade them.
Do you know which haplogroup you belong to?
I think it's R1B.
Okay.
Yeah.
Ireland Y-DNA is a good place to start.
Yes.
Okay, I'm going to go to this lady first, and then this lady over here.
Very similar question to the last with another bit onto it. I tested by proxy. My surname is Murphy, which could not be more common.
Yeah.
And I got no matches whatsoever at 37 markers. There is one at 25. I did join the Ireland DNA project, but when I was faced with my computer screen filled with numbers like this, and my results were down in the ungrouped part, I'm just wondering, is there a way I can export that data to sort it in an Excel sheet, or, it would be literally, because there are maybe 100 results or more on the page, to actually go down and mark each one with a pencil or something would be impossible. I'm sure there's a way to do it.
So, first of all, on the 25 marker match that you're talking about, was that to another Murphy or was it to someone else with a different? No, it wasn't. Okay. So that one might not be relevant. One of the things you could do, have you tried also going into the system and toggling back and forth between if you're in the Murphy project, to show matches against the entire database. Have you tried that one yet?
No, I've just last night I was kind of looking at what I could do with it, and I got tired.
Yeah. So try doing that, and then Cleanna is my Facebook friend, so email me through Facebook if you get stuck. But one of the things is there's a marker set. Let's see if I have one on a chart I can show you. Right, 464 right here. This is a multi-copy marker at 464, and it out of all the markers on there, because I've been doing this so long, I can actually like or dislike markers, and I dislike this one immensely. This one's the bane of my existence. And the reason why is because this one tends to mutate and, degrade is the word I was looking for, faster than other markers. But what it does is it repairs itself. So like on 464, you have DNA facing each other, so if some of it degrades away, the DNA will come up from here and repair itself. And the way you can tell this, and this actually happened to these people here, is because of the numbers. So like this has it's kind of hard to see the first ones. It looks like a 15-15 and a 17-17. So this 17 right here should be 16. So the 17 repaired the 16 with another 17. And then the 15, I think that's a 15, it's hard to see, but
15.
This should be a 14. The 15 repaired itself and made it a 14. So it's called a Reklo event when the DNA repairs itself. Now, this marker is helpful for some people. That's why they don't get rid of it. Even like that's the bane of my existence. But the bad part is this can also knock matches off. It can make you look like you're more distantly related than you are. So if your Murphy has something like that, they might actually be knocked off from another Murphy that you actually match. You might have a Reklo event and you're not able to see it because of mutations. I had a lion one time test, and he tested, family tree DNA when they started out, they started with 12 markers. And then by 2003 or 4, they went up to 25 markers. And then a couple of years later, they went up to 37 markers. And so as time and technology keeps advancing and they introduce more markers, with more marker panels, it's able to refine the time frame down. The 37 marker is usually around a 300 to 400 year time frame. When in the beginning, I had a lion who tested. I don't know if he's on my lion chart. Let's see. Where's the lion? There they are. So I got to stand back a sec. Richard Lyon, this lion right here. So when he tested, he first only tested 12 markers, and he's completely brick-walled in Michigan. So he's stuck in Michigan. He tested 12 markers. Well, he has a mutation right here of a 25 from the ancestral 24. So on a 12 marker panel, he didn't show as a match. So then he upgrades to 25. And on the 25, he's got a mutation right here. So again, it knocked him off, and it didn't look like he matched. He went up to 37 and he matched. He's a perfect match on the last panel. So the 464 actually helped him. And so he was ecstatic because now he knows he's from this William the Conqueror lion line. But that's one of the things that can happen sometimes is DNA just changes randomly. So those mutations can occur and knock you off from a match that you're not able to see. Another thing too, you mentioned you were in the ungrouped section. You need to contact the Murphy administrator and have him see if there is a section you should be in. Maybe he just or she hasn't gotten to that yet.
Do you know what haplogroup you are?
R1.
The Ireland-wide DNA project would be a good one to join as well. 80% of people are going to be R1b, and if you email Margaret Jones, she's one of the administrators, but if you email Margaret Jones and tell her... Margaret Jordan, sorry. And tell her that you were at the Genetic DNA Ireland conference, and she will be able to advise you on which specific haplogroup you could join. And the best way to find the Ireland-wide project is to Google mtDNA, Ireland-wide DNA. I find Googling the projects is probably the best way of actually finding them, because it can be difficult if you go to the Family Tree DNA website itself. It can be a little bit difficult to find exactly where that project is. But if you just Google it, the mtDNA and the name of the project, that it comes up fairly quickly. Now, this lady here had a question.
When you say you have a match, does that mean an exact match with no differences whatsoever? Or are you saying it's a match with, say, 4 differences?
The answer is yes. It's yes to both. You might end up with a perfect, all the numbers are the same. But if it's only a couple off, the computer will tell you what it is. But again, if it's something that's in like that 464 panel, that might not even show a match. That's one of the powers of being in a project, is because you might not always see matches. Like, let me give you on the McCallums. Let's see. As the blue ones that I highlighted are common ancestral mutations, and the yellows are just random outlying mutations. But if these people had tested and not in a project, just were floating in the database, someone like, say, him, who has 5 mutations here, and then this ancestral mutation, this gentleman, oh, and he's got one here too, he's not going to show as a match to, say, someone down here that is, especially in the 464 panel, that he's knocked off from. So that's one of the abilities and the power of being in a project, is being able to view the results so you can correlate the matches. Because, so these 2 people, because this one and this one, this Malcolm and this McCollum, they do share a common ancestor, but it may be, much more distant in time, like say 1700s, 1600s. Because this kind of DNA can go back thousands of years, and the haplogroups go back thousands of years. Something interesting on the first day that we were of this conference is Dan Bradley from Trinity University spoke. I mean, college. I keep correcting myself. University is such an American term. And then there was someone else. Oh, was it Patrick Guinness? They both mentioned that they predict that in a couple of years these STRs won't be as relevant to genealogy as SNPs. They feel that the technology is going to advance so much that you only need to do a SNP test, and that'll tell you exactly what place you came from. Now, I look forward to that day, but since I've been doing this now, this has existed 13 years and I've been doing it 10, it's hard for me yet to picture a world without STRs. Because, and especially, I mean, I can imagine, let's say you find Cleonophen's a SNP that pinpoints her to, what county is your Murphy from?
I think Roscommon is the farthest back I can get in the 1700s.
So say they are able to, a SNP is refined out that pinpoints your Murphy to Roscommon, and I have a Murphy in my rotaries. Let's say I test him and he pinpoints to Roscommon, but still to be able to refine down what particular family in a more recent time frame, I kind of feel like we might still need STRs. I don't know, I could be wrong, but it'd be interesting to see if that actually happens. Look forward to it though.
So when you say matches, you're not meaning somebody with no differences whatsoever. It's somebody with, it could be including people who have differences.
Sometimes, okay, so these two, this McCalman and McBride, they are a perfect match up to, I guess is that a 25 marker panel?
Yeah, it looks like
And they're a perfect match up to there, but this McCallum down here is still considered a match to those 2 McCallums, because then the McBride, he's actually McCallum, even though he's one off. So they're both considered matches, even though one has no changes and one has 1. Does that make sense?
Yes, and even if one had 3 changes, that would still be a match.
It depends on how many markers. If it's in the first 12, no, it's usually not. But
If it's 37, then you have 3 changes, that would still be a match.
Very likely, especially if it's a 464.
Thank you.
the mtDNA results will give you the closest match, then continue on down to the most remote match, and then you'll get all the family names, surnames that will be listed that are near matches to yours, but increasingly remote from your specific test results.
What is it, about 4
Yeah.
to 6
And then-
off, something like that?
Well, I think
Depending on how many.
I've got a lot of pages to
7.
mine, and I stopped looking at about 2 or 3.
Yeah.
I think minus 2 differences is probably the most relevant. And then on the other idea of where the results appear, If you go all the way down to the bottom of the page, you can download those results as a CSV or an Excel file, and then you can do your personal annotations or remove people from the list that don't seem relevant.
The way that I was able, because there's people in here that are have so many mutations, they don't show as being matches to people down here. The way I do it is I look at each participant's match list and see who they match, and that's how I group them. So like I would see this RM McCullum matches DR Malcolm and put them into group 4, and then I might see that HF McCullum matches RL McCullum and put them in there, and then I go through and find the patterns, because again, people can inherit a change from their common ancestor. Something that's fascinating, I heard this at a family tree DNA conference. A male can have a child when he's in his 20s, a son, and he passes that Y chromosome to him, and there's no changes. And then he has a son in his 40s, and he passes his Y chromosome to him, and there could be a change. So 2 sons might, and I've actually seen brothers who have not had a perfect Y chromosome match. You know, generally when you do this kind of testing, you don't need to test siblings and brothers and whatnot for Y chromosomes, but some people do it just because they're, they get really into this. So that's how we know and have seen it. But even that can happen, so because it changes rather rapidly, you just don't know.
One last question?
Yes, I just want to ask a hypothetical situation. You have 2 families, and you know the way you can have 4 variations, isn't it, between XY, XX, XY, Y. So we imagine that there's those 4 variations are covered. So there's 8 children. We'll say 4 of them are girls and 4 of them are boys, and they have 2 double first cousins. One is a girl, one is a boy. Okay? Is there any relevance for them, the 2, to do a cross, or for them to do a cross with them on that type of thing?
On this, on the autosomal?
Yeah. Is there any relevant? Would they find out anything interesting?
Yes, there is.
Yeah.
In simple language, just tell me.
You go for simple. I defer.
If you're going to do autosomal DNA and you're going to test a cousin, and it doesn't matter if they're double second cousins or whatever, but any kind of cousin, that is going to, if you get a match that matches you and that cousin, then it's fairly probable that that match that matches both of you is actually lying above a certain, it'll be lying above your grandfather on that particular side, because you and your cousin would share a common grandfather together. And so if a third person matches both of you, then the common ancestor has to lie above that specific grandfather. So it's a useful way of getting rid of the other 3 grandparents.
Right, I understand that, but I mean from the purely point of view of doing the exercise, is there any difference that the 2 families are doubly related? Could it be just first cousins and would you get the same result? That's basically.
You know what? I'll go ahead and answer that.
Sure,
I think I can do it kind of simply, and I'm going to use this chart. So here's the thing, that the rule is that siblings, no matter what, well, except maybe identical twins, we're going to leave them out. Siblings do not inherit the same amount of DNA from their parents. So what that means is my brother did not inherit this DNA from our Bohemian ancestor that I did. So the same situation would happen in yours, is the benefit, even though they share so much common ancestry, that they're still going to have matches that are different. So you see that they'll still have inherited, even double cousins will still have this chunk of Bohemian or whatever.
Right, so they'll have enough differences to be interesting going backwards.
To help you, yes.
Right.
We have to call it an end there because we're at 25 past. But Katherine, thank you so much for sharing your wisdom and knowledge with us. Can we please give a warm round of applause?
What's next? Who are you? Can I look you up before you say anything? How are you? Oh, well, it's good. It's embarrassing. It's just deep south.
Sorry, Morris.
Hi.
Michael Dalton told me to come and just introduce myself to you.
All right.
I'm Bernie Walsh. I'm a genealogist.